Okay, Logan. Hey, this is Rod, Anside 230 stuff. I've got three examples, three paragraphs that you submitted. I guess it was tonight. A2, A3, A4. So I'm going to drag down this first paragraph. It's the first one from your A2. And let's see. Let me get my laser started here. So there's A2, that's your paragraph, and you should know that this paragraph comes from the week. If you look at A2, it's about endocrinology. There it is right there. I'm going to enlarge your paragraph more. So let's do this. So the thing you do is this is talking about hormones, and who knows what it means. So we'll go through this. Let me get my laser pointer. Okay. An agonist is a hormone, or is a compound, I should say, that acts like the hormone. Like, let's say, progesterone agonist. That means it's a chemical that acts like progesterone. Myocytes, muscle cells. Onbound, well, there's hormones in the system that are in the blood, especially, that are bound to carrier proteins, and then there's others that are onbound. Someplace in the reading or the videos, it refers to onbound hormones as the free hormones. Endo means, within. So if you have endocrinology, that means the study of these hormones within the body. When hormones work, they have a lock and key that was in the videos. The key fits into the lock. The key is like a hormone. The lock is like a receptor. Some hormones are made of amino acids. Some hormones are made from cholesterol. All the steroids start out with cholesterol, estradiol, testosterone, cortisol, you name it. Life, well, in the videos or the reading or both, it had something about the half-life of hormones, how long they live. So you would put HALF in front of life, half-life. You could say half, HALF hyphen life. Para could be a name meaning nearby, next to. And, you might think of, let's say you did parathyroid, but para could also be used by saying some hormones have a paracrine. So in this prefix, you could add CRINE. A paracrine action means a hormone that leaves one cell and has an influence on a nearby cell. Hormones always look for their target tissue that have receptors. Okay, so let's go through this. The endocrine system mostly deals with hormones and how to regulate the body. Okay, not bad to start, I guess. Many components make up the endocrine system, like the parathyroid, which is a natural agonist. This statement right here means nothing. Like the parathyroid, which is a natural agonist. Okay? The parathyroid is a hormone next to the thyroid. It means nothing when you follow it with which is a natural agonist. Myocytes, that's all muscle cells. Myocytes are known as smooth muscle cells. They could be cardiac cells, they could be skeletal muscle cells, are target cells. Okay, you're saying myocytes are target cells. Sometimes they are, but that statement doesn't tell me anything that you know the physiology. These are the endpoint for many onbound hormones. Maybe you got that right, but onbound hormones that are in the blood can leave the blood and go into cells or tissue and bind to receptors. That's not exactly what you said. Cholesterol problems are common in today's world and are actually a cause of low hormone levels. Cholesterol is a precursor for all steroid hormone synthesis. That's why cholesterol is up here. Remember, we're doing endocrinology. This whole story has to be about endocrinology. This can affect quality of life in negative ways. Well, remember, life probably should have been used as half-life. Hormones have a half-life. They live so long in the blood and then they are digested. And let's see, amino acids play key roles in the endocrine system. Well, no. Certain hormones are made from amino acids. So you need amino acids in your diet to make hormones. So let's see, there's things missing, I guess. Let's go. Agonist, I see it there. Myocytes, unbound, endocrine, key. Anything used for key? I don't see the key anyplace highlighted. Amino, blue, life, para, target. Okay, our target cells. So you had one word missing, which wasn't too bad, but I mean, these things were nonsensical, really, some of them. You got to tell a story. An agonist is a hormone that acts like another hormone. Myocytes are all the muscle cells. Unbound. The hormones that are able to leave the blood and go act on target tissues. Endocrinology, yes, endocrine actions. Key hormones are like keys. They fit into a lock. Many hormones are protein and they use amino acids to start. Many other hormones are steroid and they use cholesterol to start. Every hormone has a half-life. That means how long are they going to work in the animal body before they're digested by enzymes. And para might be better paracrine rather than tying it to parathyroid. Paracrine hormone actions, and I know there was a video or reading on that. Paracrine action is where one cell releases a hormone, it diffuses across some interstitial fluid and affects another nearby cell. Target hormones always look for their target tissues, and to be a target tissue, you have to have receptors for the hormones. Okay, Logan, so now this is from A3, and I'm going to go up here and say A3 was 2 weeks of immunology. Let me get this thing down here, enlarge it a lot, and let's talk about it. So when you read all these keywords, you got to think about something in immunology. Well, okay, let's see. Get the laser pointer going. Genetic. Well, a lot of things done by the immune system is based on the genetics. Some people have, or animals have great genetics and others don't. Placenta, that's always a tissue that surrounds the fetus during pregnancy. After birth, our domestic animals release colostrum, especially the large farm animals, and colostrum has antibodies, immunoglobulin. The gut refers to intestine, and intestines in the newborn animal within like 24 to 36 hours can take the antibodies and colostrum, and put them into the blood. After that, they can't. Lysis means the breakup of something, and if you have hemolysis, that means the breakup of red blood cells. Type here might refer to the types of hypersensitivities there are. If you go back to some of the videos, there are 4 types of hypersensitivity. And in newborn animals, there's one that operates if there's something bad in the colostrum. Neo could be the neonate. That means the newborn. Hemo talks about blood. Hemolysis means the breakup of blood. Digested, well, let's see. The antibodies, which by the way are IgG, and every place you've used in other answers too, LGG. LGG. There's no such thing as LGG. It's IgG, immunoglobulin G. And you've had other paragraphs where there's a lot of these LGGs and it makes no sense. If the newborn animal is past about 36 hours after birth, all the antibodies coming in the colostrum are digested as if they were proteins. They don't get into the blood to help the animal fight diseases. Foals can be born, yes, and there was a full article about, neonatal, equine neonatal isourethrolysis, and you misspelled that, but at least you're on the right topic there. Foals can be born with a disease called hemolytic. No. Might be hemolytic disease of the newborn, but that's not quite correct as it sits there. An explanation of this is when the mother's blood type and genetics has antibodies compared to the foal's. Well, that means the mother might develop antibodies against the foal's red blood cells. You could make that smoother. This happens when the foal takes its first drink of milk, first drink of colostrum, and digested the colostrum. So, not making sense of that sentence. It can also happen through the mother's placenta, which does not have very often. Okay, so I'm seeing paragraphs being written and they're not even being reread and edited. It's like Logan is pumping these out and not even rereading them. You're better than that. I know you are. First mother's milk. It also contains LGG, so you missed that on all the videos and reading. That's hard to believe. That should be IgG, but colostrum has antibodies, vitamins, and something which the foal cannot live without. Don't say baby, that sounds like human, and you're talking about foals. The foal cannot live without, but sometimes it can also be dangerous, yes. If you're talking about the mother has antibodies against the foal's red blood cells, but you never said that anyplace, right? Do I see anything about the foal's red blood cells? Nope. Too much LGG will increase the blood in the foal, which will close the gut, causing antibodies not to be digested. There's a thing called gut closure. Before gut closure, antibodies get into the blood. After gut closure, the antibodies can't get in the blood, and the antibodies will be digested, just like they're a piece of meat. Okay, so that's why these paragraphs can't be assigned any higher points than what it says in bright space. Okay. And maybe after hearing this video, and there was a video earlier in the semester that said how to make the paragraphs, and maybe that would help you as well. So this is assessment 4. The paragraphs either on the neural system, muscles, or bone. 1 week was neurology. 1 week was muscles and bones. So let's get this down here, enlarge it, and then I'll get my laser pointer going. And let's look at the words. Dog, okay. Para could be paracrine, but probably not since we're doing neurology or muscles. But there's a parasympathetic nervous system that's been talked about. Digest might be the digestive system. If you're talking about neurology, there's a branch of the sympathetic nervous system that controls digestion. Atropine is a drug that can be given pre-surgery, and you did mention that somewhat in your paragraph, and it tends to decrease salivation, increase heart rate, decrease gut motility, and it has other uses. It's really quite a compound. It's an acetylcholine antagonist, and I don't see that any place in your paragraph. An acetylcholine antagonist. That's what atropine is. There's something about decrease. Well, I just said atropine decreases gut motility. Well, there's the word gut. Who knows what agent could be? You'd have to, when you write your paragraph, can you use agent? It's depends on what the paragraph reads. Antidote? Well, atropine is an antagonist to acetylcholine, and it might be used as an antidote in certain poisonings. Antidote means it counteracts a poison. Gut is referring to the intestines. In this case, probably something about their increasing their peristalsis or decreasing their peristalsis. A dog is a man's best friend. Yes, buddy, I agree with that, but there's a lot more they can do than meet size. They are very absorbent. Dogs are very absorbent. Okay? Does not compute. They have a lot of instincts, but all the animals do. One of their best attributes is their sense of smell. I totally agree on that. I mean, my gosh, one of our border collies can run past a tennis ball that we played catch with 3 weeks ago, and the sense of smell just stops him and he finds the ball. The peripheral nervous system is very vital. Okay. Controls okay, so you've got the peripheral nervous system is very vital with smells because it controls major nerves in the brain and spinal cord. So that doesn't make sense. Okay, the peripheral nervous system is outside the brain and spinal cord, so that needs to be explained better. Digestion is controlled by the autonomic nervous system. Okay, but tell us how. The parasympathetic nervous system decreases heart rate, that's right, and increases gut activity during fight or flight situations. No. The parasympathetic nervous system does increase gut motility, but during the fight or flight, gut motility is decreased and heart is increased. So those things don't quite match. When dogs need surgery, they are given the antidote atropine. So they are given atropine, which is a pre-anesthetic agent that increases heart rate. So you said atropine decreases heart rate. No, it usually increases heart rate. A side effect might be lack of saliva production, a decrease of saliva production. Yes, it does. So there we go. I mean, I'm still not seeing a good understanding. I think in this case you used all the words except agent. I guess I don't see agent. Oh, there it is right there. Is a pre-anesthetic agent. Okay, that's good. Okay, antidote. Yeah, they are given the antidote atropine. Well, you got to say atropine is an agent, pre-anesthetic agent, and in some cases it's an antidote to some poisonings like organophosphate poisoning. So hopefully you can chew on that. There's another video that's up on top of that table. It says, see this video for helpful suggestions. It's got to be a story. that make sense of the words.